All right. So today and tomorrow we'll review some stuff about gas laws because you know pretty much everything there is to know about gases, and we'll have a test on this whole thing about gases, like the gas law unit, on Wednesday. So all the materials for this unit in chapter or in unit 8. I mean, we've been at it for a few weeks now, but right at the end of the week of March 24th, um, went over like the basic gas laws, the relationship between pressure, volume, and temperature, and then Graham's law and Dalton's law of effusion and diffusion, and then did stuff with the combined gas law just on those 2 days, and last week about the ideal gas law and some concepts with boiling. So in the plan for the week, there's a little link here. It says link to the codes. I think it's also on, yeah, on the bottom of the thick packet. It says digital link, but you're gonna have to use your Chromebook anyway. So if you go into the plan for the week, this thing here says link to the codes. So if you click where it says link to the codes, as the mission objective. So we did one of these escape rooms earlier in the year. This is like a gas law escape room, and when you click next, it shows like this little kind of puzzle thing here. Anyway, uh, in the escape room gas law thing, that paper, there's some different concepts. So, for instance, level one, question one. So you did level two and three on Friday, actually. But if you increase the number of gas particles, which of the following is a way to increase the pressure on the gas? So, like, which of these four things is an option? Now, if question one, you say, oh, it's B, then like, uh, hold on, which way does it go? Oh yeah. So if level one, you think the answer is B, then on this map, you go to B and then you follow the little squiggly thing. And if it ends up with a three, then the code for that is like a three. Does that make sense? There's four different questions. Question one, two, three, and four. And there's the squiggly thing on the back to match the numbers with the letters. So in other words, um, if question one, the answer is B, then you follow the squiggly and it gets you a number. So then if B aligns with three, then the first digit in the four-digit code would be a three. So if you put the correct four-digit code in here and hit next, then uh, then that's the escape code that goes down in the lower right-hand corner. And there's unique sets of codes for each of the individual problems. But level two and level three, you did that on Friday. So whatever you have for your level two and your level three, I checked them and I made any changes on your paper if you made a mistake, but I put them back on your desk. You can fill in the level two and level three directly on this paper. So this is what you turn in for credit. Let me give you some other heads up about ways in which to know gas laws in an easy way. The laws that are important are the combined gas law. So this is a way that you should start the problem is to say, well, if I know there's a change in a situation, the combined gas law is good for dealing with changes. In other words, there's some starting condition and some final condition, one and two, like a before and an after. I know a starting pressure and volume and a final pressure and volume. If in the problem there's a constant temperature, you know algebraically that if the values of the denominators are the same on both sides, then those values can cancel out. So in other words, if T1 and T2 are the same, then really the combined gas law, P1 V1 over T1 is equal to P2 V2 over T2. Those temperatures end up canceling out, leaving you just P1 V1 is equal to P2 V2. And that's how you wrote Boyle's law. Similarly, if you have a problem with a constant pressure, then starting with the combined gas law, P1 V1 over T1 is equal to P2 V2 over T2. If the pressure does not change, then the pressures cancel out, and you're left with the relationship V1 over T1 is equal to V2 over T2. Similarly, if you have a constant volume, so in other words, there's a volume of a gas, maybe it's like a scuba tank. The volume of the gas can't change. It's a rigid fixed container, can't expand or contract. In the case of a constant volume, when you start with the combined gas law, P1V1 over T1 is equal to P2V2 over T2. If the volume can't change, then V1 and V2, those cancel out in the equation, leaving you P1 over T1 is equal to P2 over T2. So an easy way to derive the basic gas laws that we did 2 weeks ago is always to start with the combined gas law, and then anything that is constant, that variable just goes away in the equation. So if you know, like, uh, I don't know, like you have a garbage bag and it's sealed and it's got some air in it at some temperature, if you then cool that air inside, the volume is going to decrease by this same proportion. So the ratio of the volume to temperature, oops, that should be T1. I don't know why it says T2. T1. Sorry about that. Oh, that's the wrong color. T1. There we go. Is equal to V2 over T2. Same thing over here. If you have a fixed volume, the ratios of the initial and final temperature, or initial pressure to temperature to final pressure and temperature are constant. Then the only other thing that's important is when there's not a change, but you want to relate quantities of gas, quantity in a molar quantity. I don't know why that happened. This molar quantity, which is going to be important as we do more stoichiometry. So basically, like we're going to keep on relating quantities and chemical reactions, but now we can do it with gases. The rest of the course will do things with concentrations of solutions that are, what do you call it, like aqueous solutions, and then deal with acids and bases. So then by the end of the course, you'll understand all the basics of reaction chemistry and chemistry measurement and acids and bases, gases and whatnot. That's a good head start to do a bunch of things in future courses. So this stuff about gases is actually a jumping off point to a large unit in heat and thermodynamics that we do in AP Physics 2. It's also the starting point for understanding atmospheric science, because in meteorology, the atmosphere is just one big sample of gas, and understanding changes in pressure, volume, and temperature is the fundamental thing to know about meteorology. And then if you take AP chemistry, everything in this course is all in AP Chem, and that's the beginning of the work with gases and AP chemistry. So we go over all these ideas again in those courses, because sometimes students don't get it the first time around, or may not have taken chem in the right order or something like that. Because once in a while, a student will be like a year ahead in, what do you call them, elective sciences and stuff like that. Sound good? All right. Yeah, you're gonna have to use your Chromebook to get to the thing. The easiest way to get there is in the plan for the week. Just go to, or in the this week, go to the plan for the week. There's a little link to the code. Otherwise, you can type it in, but it's kind of a pain. It's bit.ly, and then it's two. That's a 0S5 capital M capital C lowercase n, and it's case sensitive. So if you don't get the cases right, then it's kind of a mess. What's up? Yeah, that's fine. And then I can link it for remote students. Yeah, we'll just do it on paper. So if you're remote, here it says, oops, I need to turn this off, unpublish. Or wait, hold on. Nope, that's the one. Yeah, so if you're in class, you can just turn in your thing. It says the answer sheet. That's this. It's not the answers, but it's the answer sheet. If you're remote, instead of like completing it on this paper and submitting it or whatever, we're going to make a little submission spot that's like a quiz. This thing, your code submission for escape room. Here, I'm going to assign this only to, what day is today? 19th. Make this tomorrow. Enable, individually assign. Let's see. Yeah. So if you're remote, the easiest way to do the whole escape room thing. So on Friday, you may have done parts 2 and 3. And if you didn't do part 2 and 3 on Friday, you can do that today too. I can show you how to do that in a second. But this this is the link. I put the link in the plan for the week to the page that unlocks the code for you. So level 1 is what students are doing in class today. Level 2 and 3 actually did on Friday. And once you get level 1, 2, and 3 done in this digital link, that's where you put your answers to level 1, 2, and 3, and it'll give you a completion code. That completion code you would write here, but you can just do that in this little submission spot. So here it says code submission spot for escape room. It's like, what's your number code for level 1? What's the completion code after the escape room? And if you couldn't get the right codes and you want me to see like what you did and be able to help you and give you feedback, there's a little file upload section there. So then how the escape room activity works anyway, the escape room all puzzles file that has levels 1, 2, and 3. Really, they're just gas law problems. So it's not like just an escape room game or something. But let's see. Yeah, so this is the link that I have in the plan for the week, or you can just type it right in. Your mission is to escape the room getting gas law questions correct. So for instance, question 1, which of the following is the way to increase pressure on a gas? If you happen to think that it's C, then for question 1, it's C. And then what that refers to is, if for question 1 you get C, when you go to this level 1 clue, from C you follow the thing and it goes around to 2. So then the first digit in your level 1 code would be 2. Well, there are 4 questions here. Questions 1, 2, 3, and 4. Once you figure out what the letter answer is for 1, 2, 3, and 4, you follow those down to the number code. So for instance, your final code may be like 3241 or something like that. And the code 3241 is entered for your level 1 code at this site. And then level 2 and level 3, level 2 and 3 are a little bit different. Level 2, there are some problems. They're combined gas law and ideal gas law problems. And so, for instance, if you do this problem here and you happen to get an answer of 1.64, which would be like 1.64 liters, then R goes in any space that says 1.64, which would be here. So this might be an R. I'm not saying that it is, but it could be. Sometimes, like if your answer for this is 635, there's a D that goes both here and here because they both say 635. This will spell something out, and it should be a phrase that makes sense. So if it doesn't make sense, you may have something incorrect, and you might want to just go back and double check whatever letters that don't seem to make sense. Level 3, here when you do this problem, you may get a pressure of 2.1. So if you get this answer and it's 2.1, then you follow the path 2.1, it takes you to B. And then maybe you get the answer to this and you get 2.35, takes you to C. And maybe you do the answer to this and get 586, it goes to G. But you get from A to the escape somehow through a path on this. And whatever letter path you end up taking, that letter path is what goes in the answer sheet. But you don't have to fill out this answer sheet and submit it if you're remote. Instead, you can put your code, your code from this in on the submission. Anyway, if you have questions during the period, you can put them in the chat, and I'll watch that and be able to help you out. Let me see more.